Okay, this is lesson 22, exponent properties. We're going to build on what we did last week with exponents. Okay, so remember, exponents is a different way to write multiplication problems when we have the same thing being multiplied over and over again. The thing is, when we have more complex problems, then we have to know how to deal with them, except that we've figured out some properties of exponents, so we're going to continue working on some. These are the steps for today, same thing as Friday. If you're on the video, stop it here. I'm going to move on right now. Sorry about that. Ooh, I'm messing this all up. So, a little bit of a review from last week. Anything to the 0 power is 1. Good. Good. Anything to the negative power, how do I get rid of a negative power? We flip it. We know we can make anything a fraction by putting it over 1. And then this, we don't like this negative power, so we put it on the opposite end of the fraction. So this is going to be a to the nth power. So we have 1 over a to the nth. Good. Anything to the first power is?
Itself.
Itself. Good. Okay. Okay, let's add on to this. Now you're going to write these as I go. Okay, these are just the properties. So these aren't the examples. So here we go. The next one. Let's look at this property here. This is the product property of exponents. So when we have two exponents with the same base, you see how it's a and a here, and they're being multiplied. We're going to take the actual exponents and we're going to add them together. So a to the m times a to the n, we're going to multiply. So it's going to be a to the m plus n. So a to the m times a to the nth. This is also like, we could do it like this. This is how it applies. Let's say I had a base of 2 on a problem. I need you guys to end your conversations, please. Thank you. I know it's still not an appropriate time right now. Let's say we had 2 to the 5th times 2 squared, okay? This becomes a big complex problem. Since these are both the same base of 2, I could maintain my base of 2. My answer is going to I just need to add the exponents. So 5 plus 2 is 7. So this is the answer for this type of problem, okay? Same base of 2. They're being multiplied. We're going to have 5 and 2. We're going to add it together. So it's 2 to the 7th power. Did y'all see that? Okay, write this down in your notes, please. This is just this property. We're going to keep going here in a moment. So if this one was multiplying 2 of the same base with different exponents and we added them together, what do you think would happen if we divided them? What do you think we're going to do with our exponents? Subtract. That's right. We're doing the opposite, right? So on this one, that's exactly what's happening. A to the mth divided by a to the nth is going to be, we're going to subtract it by having a to the m minus n, okay? Here's an example of that. Let's say we had a base of 3, okay? So we'd say we had 3 to the 10th divided by 3 to the 7th, okay? Bases are the same. They're being divided, so I subtract. What's 10 minus 7, everyone? 3, so it's 3 to the 3rd is your answer, okay? And of course, what's 3 to the 3rd? What's 3 times 3 times 3? 27, right? But for the sake of this example, let's leave it like that so you know what the rule is, okay? So write this one down now, please. Yes. We don't make them, we just leave it as the same base. Now, Dalton, what happens if the bases were different? Could I use this rule? No. Okay. Okay, continuing on. Then we have this one right here, ab to the nth power is equal to a to the nth times b to the nth. What this means is we have an inside term. Let's say they're both being multiplied, a times b, all to the nth power. You're going to distribute this n into each of these internal terms of the expression. So we're going to raise a to the nth times b to the nth. Here's an example. Look up here. Let's say we had 5x, all of it squared. Okay, we're going to take the squared term and we're going to distribute it to the 5. What's 5 squared, everyone? What's 5 times 5? 25. Good. What's x squared? Just x squared. There's an example of how this works, okay? Please write that one down. Well, actually, I lost 2 examples. Same thing if we have a division inside an expression that's being divided, a divided by b all to the nth power, where you just take the n and you distribute it to each of the inside terms. You see how it's going into each of the letters here? Okay. So, and your answer is going to be a to the nth divided by b to the nth. You can start writing this down, but I'll give you an example. Let's say you had 5 divided by x, okay, all squared. Okay, we take the 2. What's 5 squared, everyone? What? 25. And then what's x squared? X squared. Just like that, you see? So this becomes that. Did y'all see that? An example of this on the bottom left, a to the nth raised to the nth. Let's say that we had 3 squared raised to the second power. Okay? Well, we keep the base of 3, and then we multiply. What's 2 times 2? 4. That's your answer. That's the simplified version. We're adding, or I'm sorry, we're multiplying the exponents, 3 to the 4th. Okay? So we've learned a lot today. Let's do some talking now before we apply these, okay? Numbers 1 and 2. Let me show you 1 and 2. That way you can see how it works. Do not do it, so just put your pencils down. You're just watching right now. Okay? Whenever you do any problems with exponents, you go from left to right. You organize it doing the coefficients first, okay? This is a multiply problem, so we got 2 times 2. I asked myself, what's 2 times 2? It's 4, right? And it's positive 4. Okay, then I work on my first letter. There's only 2 letters in this whole problem, M and N. Please stand up. Okay, M and N. Okay, so we have M to the 5th times M to the negative 3rd. They're being multiplied, so I have 2 exponents, same base. We're going to add the exponents. What's 5 plus negative 3? 2, right? So then we're going to write times m to the second power right here, right? Then the next letter is n. We have n to the first power here. You're watching right now, not writing, because you're going to miss something really important. Are there any n's here? No. There are really, how many n's? N to the what power? 0 power. Okay. What's anything to the 0 power? It's not itself. It's 1. What's 1 times anything? Itself, right? Good. So we have n to the 0 times n to the first. What's 0 plus 1? 1. So we're going to write n to the first here. And now we're going to simplify this. We got 4 times m squared times n is 4 m squared n. That's your final answer for number 1. Again, you're working one piece at a time. Do coefficients first. 2 times 2 was 4. M to the 5th times m to the negative 3rd is m squared. N to the we didn't have any n's here, so I added n to the 0 times n to the first. We add them is n to the first. So we got 4m squared times n. That's it. Make sense? Okay, number 2. We got negative 2y to the negative 2nd raised to the 2nd power. We got this 2nd power over here on the top right. We need to distribute it into each of the subsequent terms. So we got negative 2. Negative 2 squared is like saying negative 2 times negative 2, which is positive 4. Okay. Then we got y to the negative 2nd raised to the 2nd. We are raising a power by a power, so we got y to the negative 4th. Okay. We don't like negative exponents like last week, so we're going to put this into a fraction form and move just the y to the negative 4th to the bottom just to make it positive y to the positive 4th. And that's it. Make sense? Questions on 1 or 2? Okay, right. Before writing this on, let's have you turn to your neighbors. Let's have one still. Let's work on this together. Working on the coefficients first. What's the coefficient in front of the first term here? What's the coefficient that's here? Is there something there? Yes or no? No. What's the imaginary coefficient we should imagine that's there automatically when there's nothing there?
0.
A 1. Right?
Yeah.
There's an imaginary 1. It's redundant. In math, just know any coefficient that's not there is automatically a 1. Okay? Alright, so coefficients first. What kind of problem is this whole thing, by the way? Add, subtract, multiply, divide. Add, good. Okay, so what's 1 times 3? 3, good. Just work slowly. What letters are we working with here? Name the letters.
U and V.
Okay, what letter do you want to work with first?
U.
U, okay, good. We got u to the 4th times u to the 5th. Are they the same base? Yes, okay. Tell your neighbor what you would do with the exponents. Okay, so what should I do, class? So it's going to be u to what power? What? U to the 9th, right? Because 4 plus 5 is 9. Good. What's the next letter that's up here? Okay, good. Are there any V's in the first term? No, so let's put V to the 0 there just because we want to put like a place marker. Does it change anything when I put V to the 0? No. What's anything in the 0 power?
1.
Good, 1. Okay, because anything times 1 is itself. Okay, so V to the 0 times V to the negative 4th is?
3.
What do you do when you multiply exponents together? You what? Add. So what's 0 plus negative 4?
1.
Negative 4, right? So it's V to the negative 4th. That's what we're practicing. Guys, I need you to focus, okay? This is hard stuff, and if you get it earlier, then you won't have to struggle through it, okay? Are we done? No. Okay, so V to the negative 4th. Do we like that? No. So do we need to move anything else but V to the negative 4th? No. So we're going to put a 1 here. I want you to finish up the problem for me. Go. 3 times u to the 9th, v to the negative 4th. We're going to move this to the denominator. Okay, so we got v to the 4th. The numerator is 3 u to the 9th power. Okay? Does that make sense? Do I move everything to the denominator? No. We just the v to the 4th. Good. Okay, next one, number 4. Let's do this one together. What's the what kind of problem is number 4? Is it add, subtract, multiply, or divide? Nope. What's this bar in the middle represent? Division, right? Okay, good. So looking at my first term, it's the numerator. What's the coefficient in the front of the numerator, everyone? Negative 8. What's the coefficient in the bottom? Negative what? Negative 1. Okay, good. Let's work on the coefficients first. What's negative 8 divided by negative 1? 8. Good. So we're just going to write 8 as in our answer here. Okay. What letters do I have here?
V and U.
V and U. Okay. What order should we go in? Alphabetical order. So let's work on the U's. Are there any U's up here in the numerator? No. So let's put a place marker for the U's. U to the 0. What's u to the 0 divided by u to the 4th? What do you do when you have to divide exponents? Good, so we have to subtract. What's 0 minus 4? What? Good, remember there's 2 teams fighting. 0 is a positive team, okay? 2 teams fighting, who's going to win? Negative by how much? 4, right? So u to the negative 4th. Keep going. Finish up the problem for me now. You have the v's. V to the 8th over v squared. I'm going to give you 30 seconds. Go. What's v to the 8th divided by v squared? V to what power? What's 8 minus 2? 6, right? Oh, not 2. 6. Okay, makes sense? Okay. That's our answer, right? Is that my final answer? No. What do we not like about this answer? The negative what? Negative exponent on negative 4, right? So we want to move that to the denominator, so you're going to rewrite this as 8v to the 6th power. These stay on the numerator, and then u to the 4th in the denominator. Make sense? Okay, next one. Number 5. I'm going to give you 30 seconds. You should be done in like 5 seconds. Ready, set, go. 1. Anything to the 0 power is 1, right? Did y'all get that? So on a test, listen up. Whenever you see anything in the 0 power, if you want to go quickly, just know it's 1. That's a fast answer. It should take you how many seconds?
Less than 5.
Maybe 10 at most. Okay. That's right. This is fun stuff. Ha! It's fun. Okay, good. Okay, next one, number 6. I'll start this off. Shh. Last one. Let's get this done. Okay, we have all of this in parentheses, all raised to the 4th power. So let's work it out one step at a time. We got -4 raised 4 times, right? So we have to ask ourselves, what's -4 times -4 times -4 times -4? Okay, and then you have all of these that you're going to raise a power by power. How do you raise a power by power? What rule do you use? Do you add, subtract, or multiply, or divide? Okay, work it out. Last one. I need you guys to focus. Try. Still. What's m to the -1st raised to the 4th power? What's -1 times 4? -4, so this could be m to the -4. What's n to the -1st raised to the 4th power? -4. Do we like negative exponents? No, so this is really going to be 256 all over m to the 4th, n to the 4th. Okay? All right, that's it. That concludes today's lesson.